So let's try to understand about the ideal gases. So the specific heat, the entropy, specific entropy, this also varies as with the temperature. So what we can do that with reference to absolute zero, the same formula over here, this formula and this formula can be written in terms of the entropy taken with reference to 0 Kelvin and a certain temperature. So I will say Cp at that temperature dt over d equals to S naught with reference to absolute zero. And this is convenience, and the same formula can be written in terms of S naught, S naught 2, S naught minus S naught 1, and minus R ln P2 over P1. Another thing, if you consider isentropic process, means delta S equals to 0, because entropy is constant in the isentropic process, and you do rearranging the equations, you get the relationship between the temperature and volume, and temperature and pressure, and pressure and volume. This is where K equals to the ratio between specific heats, and this can be written K equals to this ratio. So let's solve this problem. You have to find out the nitrogen, which is at 900 kilopascal and 300 Celsius, expanded adiabatically, which is kind of a reversible adiabatic process in which the no heat transfers in a closed system to 100 kilopascal. So determine the minimum nitrogen temperature after the expansion. So you have to find out the temperature of nitrogen after the expansion. So the temperature is given, so I'm gonna use this formula here. I'm gonna use this pressure for this one. I'm gonna use this formula here. So T2 over T1, P2 over P1, T1 so initial temperature is 300, and I can write down 300 plus 2. Make sure this is in Kelvin. So this is pressure ratio. P2 it is equal to 100 kilopascal, P1 it is equal to 900 kilopascal. So with that K, so looking at the specific heat ratio and K from the table A-2B. So table, if you look at the table A-2B, so you can find out the K value is 1.3914. Nitrogen, so you can write down 1.391 minus 1 over 1.391, and if you solve for this, you get this answer, 09 Kelvin, the final temperature.